All right, here's our video today, Algebra 2, dealing with arc length. Sounds fancy, right? So what is the arc length? Well, it's a portion of the circumference. It's a part of the circle. So let's get a circle going. All right, here's our circle. Get our pen going. I'll choose red. So we'll pretend this is the center of the circle over here. Here it is. And we're making a central angle. There's our central angle. And this part here, we'll use yellow. Well, green. Well, that doesn't matter. No, definitely green. Can't use yellow. So this part here, this distance here, this length is the arc length. It's simple as that. That's the arc length. And in this video, we'll talk about how to get that length. And they use the symbol S for the arc length. So simply, here's the formula. And then we'll do a couple of problems, right? So the formula is to get the arc length, you're going to do 2 pi r, and that should be familiar with you. What is 2 pi r? Well, that's the circumference. Just think about it. Like I said before, the arc length is a portion of the circumference. So if you want to get the circumference formula, so let's write that out. If you want to get the circumference, the distance around the circle, it's that. That's the formula, 2 pi r. Some people use they use pi d. You can use pi d also. Some people are taught pi d. Some people are taught 2 pi r. So that's the formula for the circumference. So to get the arc length, remember it's a portion of it. You're going to do 2 pi r times the degree. We need to find this degree in here. Whatever that degree is, we'll say theta, or theta, whatever you want to call it, over 360. So normally they just use theta or theta. Theta, whatever way you want to say it. And so there's theta. So let's do a problem. All right, so here's our big circle. And why don't we use purple? Why not? So there's an arrow showing you that's the S. We're trying to find the arc length. And let's say that we'll just use C and D. You can use any letters. And let's say theta, we know that the degree of theta, let's say it's 83 degrees. So we have the degrees, and now we need to know what R is, and let's say R is 6 centimeters. So we have everything we need to get the arc length. So remember the formula, it's 2 pi R, right, times theta, whatever theta is. In this case, we know it's 83 over 360. So why don't you pause the tape, see if you can find the arc length. And get your calculator ready. So we know it's 2 pi, and then we're saying the radius is 6, so we're going to have 12 pi, right? 6 times 2 is 12, so we have 12 pi. And we're going to times it by what? By whatever theta is. So let's just make a little line over here, division sign, and we're going to have 360 on the bottom and in the dividend, and a divisor up here on top. Well, in the divisor, that is. And on the top here in the dividend, we're going to times it by 83. Right? Dividend on top, divisor on the bottom. Well, that's not really important. So we just multiply this with your calculator, and you'll get probably the decimal over here. You get more numbers like that, and just divide it by 360. And so we're going to get a roughly 8.70 centimeters. Right? So you might have gotten 8.69173. So just round it to 8.70. So that is the arc length. So the length CD would be 8.70. And sometimes what they'll do is they'll put also a letter in here. We'll just say E, right? So you can say that's the symbol here. Arc CED, whatever we're using with letters, equals 8.70 centimeters. See, that symbol over there. All right, let's do another one. Let's clear this out. Rewind if you need to. Now let's say that theta is, let's say, 72 degrees. It's getting a little cooler. And let's say now we'll use, why don't we use A over here, and we'll put B over there, and we'll put C over here, ABC. So we know this is arc ABC, the arc length ABC. And let's say the radius is 9. Now we have a radius of 9. And let's say, I'll write the problem. Find the length, spell length right over there, right? Let's find the length, there we go, of arc ABC, arc length ABC. And then we'll say given that the radius is 9. Given that the radius is 9. So what should we do? Well, we have 2 pi r times theta over 360. And we know we're going to have 2 pi 9 times 72 over 360. Right? And if we put that in our calculator, we'll get 18 pi times 72 over 360. And so what will be the length? It'll be about, oh, by the way, let's add something. Let's say, because you'll see this most of the time on the test, they'll say round it to the nearest hundredth. So if we round it to the nearest hundredth, then we're going to say that our answer is 11.31. Should have got 11.31. So this would be 11.31. All right. Now here's something to think about also. If this is 11.31, let's use green for a minute to show you. This area right here is 11.31, not area, but length. This length is 11.31. Then what is the length of the rest of the circle? So let's think about something. I'm going to clear this out. Clear that out. Let's go back. Let's use magenta. Again, I'm going to have 72 degrees. That's 9. We know that's 9. And we know the length already. We know this length. You know, we said that was A, B, C. And we know already the length was 11.31. Rounded to the nearest hundredth. So what would be the rest of the circle? So just using a proportion, we know that 72 degrees over 11.31. And if we wanted to find what the whole circle should be, well, the whole circle is 360 degrees over x. So we can do a proportion like that. So if you get that, you're going to have 72x equals, so let's just do this. We're going to say 72x, just doing a proportion here, right? Cross multiplying, times that, right? And we'll get this. And then we divide out the 72, just doing a little algebra. And so we know that x would be 56.55. The entire circle should be 55.55. And if we're using measurements, centimeters or inches or miles, whatever we're using, the entire one. So if we subtract, if you subtract 11, happened to our pen there, we subtract 11.31, we can get an idea of what the circle would be, the rest of the circle would be. Just subtract. There's a 4 there, there's a 2 there, there's a 5 there, there's 45.24 roughly centimeters or inches or whatever we're using. So the entire circle is about 56.55 centimeters. The arc length from ABC arc length was 11.31. And so the rest of the circle would be 45.24. So let's do that also. Let's just say that we wanted to find the rest of the circle, and we didn't do it this way. We did it another way. There's another way we can do it. So what do you think the other way is? Well, if there's 72 degrees here, then the rest of the circle, we'll clear that out, the rest of this circle right here, that should be 288 degrees. So if 72 degrees is 11.31, then 288 degrees should be what? Just do proportions. And if you put those in proportions, you'll find it's about 45.2 centimeters. So that's arc length.